In this video, we'll be looking at stereoisomerism in alkenes. In the previous video, we've already talked about that alkenes are characterized by carbon-carbon double bonds, and because of that, they are unsaturated. They are also called olefins. Now, stereoisomerism is a phenomenon which arises when different compounds, although they are with the same molecular formula, they have the same structure but differ in their spatial arrangement. What we mean by that is that they are compounds with that have different configurations. They have different configurations. So since stereoisomers are different compounds, because of that they have different properties. You need to note that they do not have different conformations. They are not different conformation of the same compound. They are different compounds. So in stereoisomerism, we have two types. The first one is geometric. Then the other one is optical. Under the geometric, we also call it the cis-trans isomerism. Now we know this because of the existence of different configuration for a given structure, which may or may not be optically active. If we take a look at an example, because in alkenes there is rigidity imposed on the compounds because of about the double bond. The double bond don't rotate. So if, for example, we have this compound, let's say we have methyl here and we have methyl, and here hydrogen. Now this is butene. The double bond is on the second carbon atom, so but2-ene. Now if we also have this, here we have methyl group and here we have methyl group. Here is hydrogen, here is hydrogen. Now this is also but2-ene. This is also but2-ene. But we need to note that we call it cis if identical or similar atoms or group are on the same side. And we call it trans if a similar or identical atom or group is on the opposite side. Here, methyl group is on the same side. Because of that, this is cis, the same side. But when they are on opposite side, we call them trans. So this is cis but2-ene and this is trans but2-ene. If we have another example, and let's have this. If we are to name on this one, we have 1, 2, 3, 4, and 5. So pentene or pent2-ene. Pent2-ene. Here is also pent2-ene or 2-pentene. Pent2-ene. Now, for us to know if they are trans or whether they are cis, the carbon atom carrying the double bond here has one hydrogen. This carbon atom also carrying the double bond also has another hydrogen here. So you can see they are on opposite sides. Because of that, this one is trans. Now let's come on this one. This carbon has one hydrogen. This one also has another hydrogen. The hydrogens are on the same side, and because of that, this one is cis. Cis